This video is about the empirical rule. The empirical rule is very important for understanding what it means to be normally distributed. In addition to being symmetrical and bell-shaped, a normal distribution requires that 68% of the population be within one standard deviation of the mean, that 95% be within two standard deviations of the mean, and that 99.7 be within three standard deviations of the mean. I want to break this down a little bit more for you. If we look on both the left and right hand side, because of symmetry, we can take this 68% that's within one standard deviation and cut it in half and say there's 34% on each side within one standard deviation. Going a step further, if there's 95% within two standard deviations, if we take this 95% and cut it in half, there's 47.5% in between two standard deviations of the mean. If we're concerned just about one side, we can take that 47.5 and subtract the 34, the purple region, and get the orange region, which is the region sandwiched between one and two standard deviations of the mean. Finally, let's look at this blue region, the region between 2 and 3 standard deviations of the mean. So 3 standard deviations from the mean on both sides encompasses 99.7% of the population. So the right-hand side encompasses half of that, 49.85%. And if we want just this blue region sandwiched in between 2 and 3 standard deviations from the mean, we're going to take the 49.85, subtract the 34, subtract the 15, and left with 2.5% sandwiched in between 2 and 3 standard deviations of the mean. Finally, what about this teeny tiny portion that's outside here beyond 3 standard deviations? Well, under the entire curve is 100%. The right-hand side encompasses 50% of the population. So if we take the 50%, subtract the 34, subtract the 13.5, subtract the 2.35, we're left with only 0.15% of the population beyond 3 standard deviations of the mean. So I'd like to take a look at a homework problem from my math lab. Fuel economy estimates for automobiles built one year predicted a mean of 26.8 miles per gallon and a standard deviation of 5.2 miles per gallon for highway driving. Assuming that a normal model can be applied and that the empirical rule exists and is in place, pick the correct graph. So I did the mean 26.8 and added 1, 2, and 3 standard deviation and came up with some boundary values, 32, 37.2, and 42. I did the same by subtracting 1, 2, and 3 standard deviations and came up again with some boundary values. As we look at these boundary values, the only one that has all 6 of these boundary values in place is graph C. So it would be graph C. So I restated the problem, and then in what interval would you expect the central 95% of the autos to be found? Having completed part A, the graph indicates it would be between 16.4 and 37.2 miles per gallon, again, based on the graph in A. About what percent of autos will get more than 32 miles per gallon? Well, 68% get between 21.6 and 32. 100% minus that is 32%. So 32% is either getting more than 32 or less than 21.6. So if we want to know what percent get more than 32 would be this upper tail, and this upper tail would be half of that figure. The both tails combined are 32%. So this upper tail all by itself is 16%. Now, what about the percent of autos that get 32 to 37.2%? Well, you can actually look back to slide 4, and you can find that value on slide 4, which says that this area in here, or percentage in here, is 13.5%. Or you can think through it. So from part C, 16% get more than 32 miles per gallon. 95% get between 16.4 and 37.2%. That's the middle 95%. So that if you take 5% away from that, you're subtracting the two tails. If you only want to subtract one tail, you'll find that this upper tail is 2.5%. So if you take the bigger tail, which is 16%, and subtract off the smaller tail, which is 2.5%, you come up with 13.5%. So again, the reasoning is find the area above 32, find the area above 37.2, and then subtract the smaller area from the bigger area. So this is what I'm getting. Above 32 is 16%. Above 37 is 2.5%. So what's the overlap? The overlap is the answer to the question, 13.5%. And finally, we're asked to make a statement about the gas mileage for the best 2.5% of the cars. Well, the middle 95% gets between 16.4 and 37.2. So the two tails combined are 5%. What's left over from 95%? So it stands to reason by symmetry, half of the 5%, 2.5, is up here, and half of the 5% is down here. So 2.5% are getting better than 37.2 miles per gallon. The answer to the question is 37.2 miles per gallon.